They weren't here when the first forests grew back after the Ice Age. They weren't here when the mastodons died off, or when humans crossed old land bridges and scattered across the continent. They weren't here when the ancient mounds were built, the rivers named, or the land burned and seeded by hand. They came later, much later. The earthworms of North America, those wriggling, soil-churning, compost-digesting icons of garden life, are, for the most part, foreigners. Specifically, European and Asian in origin, not native, not ancient, not original. The story begins sometime after 1600, when colonial ships began to deposit more than soldiers and settlers on the coasts. In the ballast soil of vessels, the root balls of transported plants, and the muck packed around cargo, came passengers no one noticed or invited, cocoons, egg cases, entire earthworms, survivors of the voyage and founders of a quiet takeover. The forests they entered had no evolutionary history with them. Northern soils, scrubbed clean by glaciation thousands of years earlier, were wormless. The ecosystems had developed without them. The soil itself, from top to bottom, was a layered record of time, leaf litter, ash, clay, season after season, undisturbed. And into that archive, the worms began to dig. Not all worms, of course. North America is home to a handful of native species, mostly limited to the unglaciated south. But the worms now found blanketing gardens, forests, fields, and archaeological sites across the United States and Canada. Lumbricus, Aporectodea, Eisenia, Amynthus. These are immigrants by every definition that matters. That may seem like a footnote, but it isn't. It's the start. If we are to understand the great architectural divide between the hemispheres, why North America is covered in ancient earthworks and Eurasia in megalithic stone, we must begin with the soil, or more precisely, with the hidden biology of that soil. In the Eastern Hemisphere, earthworms have been continuously present through glacial and interglacial cycles. Their activity is ceaseless. Every season, they churn the upper horizons of the ground, digesting organic matter and pulling particles from surface to subsoil. Over decades, centuries, millennia, their burrowing acts as a kind of slow-motion erasure. Layering is destroyed, compaction is loosened. The precise and delicate stratigraphy that gives archaeology its chronological resolution is dissolved by life itself. In such an environment, any construction using earth alone is doomed to vanish. Time collapses in the soil, not because of fire or flood, but because the very agents of biological productivity, the worms, are incompatible with preservation. The only structures that could outlast this living decay were those made of stone, heavier, harder, inert to the jaws of invertebrates, and the tongues of microbial ecosystems that dance through worm trails. This is not simply a matter of cultural preference or technological advancement, it is an ecological constraint, a necessity imposed by the unseen biological engineers beneath our feet. By contrast, in large parts of North and South America, especially the glaciated regions of the north and the anthropogenically transformed landscapes of the Amazon, there were no such constraints, at least not until relatively recently. After the Ice Age, the soils of the northern continent were reset, cleansed of native worms by advancing and retreating ice. What followed was a long, wormless interlude, a period in which soils could stratify without mixing, in which compacted layers could persist, and in which human intervention, layering, shaping, burning, burying, was not undermined by subterranean life. This ecological gap allowed Earth to serve as both material and medium. Mounds, berms, embankments, and geometric enclosures built of soil could survive not just decades but millennia, and in some cases they did. Thus, the material divergence of prehistory, Earth in the Americas, stone in the Old World, may not reflect parallel lines of unequal development but instead parallel responses to different ecological baselines. A shared behavioral pattern expressed in different substrates. The builders were the same in principle, shaping their environments, manipulating form, symbol, and space. But in one hemisphere, their choices remained legible. In the other, much was erased. The archaeological record is not a neutral archive. It is a filter, a sieve through which the acts of the past must pass, and only some survive. That filter is shaped not just by culture or climate, but by biology, particularly the biology of soil. Among the most critical of these agents are earthworms, whose burrowing, feeding, and casting behaviors alter the very architecture of the ground. In regions where they are abundant, stratigraphy becomes a temporary condition. Layers are mixed, artifacts displaced, chemical signatures diffused. Time collapses downward into indistinction. In regions where they are absent, the story is different. There, soil can remember. Nowhere is this contrast clearer than in the difference between earthwork preservation in the Americas and the scarcity of comparable evidence in much of the Old World. In North America, especially across the glaciated Midwest and Northeast, monumental constructions of Earth remain not only visible but stratigraphically intact. The great complexes of the Adena and Hopewell cultures exhibit carefully layered mounds, interbedded clays, burned horizons, ash lenses, and gravel fills arranged in coherent sequences. At Poverty Point in Louisiana, concentric ridges more than 3/4 of a mile across, constructed nearly 3,500 years ago, still stand in topographic relief, with discernible soil transitions in profile. In the Amazon, deforestation has begun to reveal vast geometries, ditches, berms, platforms, beneath the forest floor. Many of these show little evidence of post-construction mixing despite their age, a testament to soil stability over time. Micromorphological studies confirm the pattern. In Hopewell mounds, for example, the internal composition includes silt caps and stratified fill with preserved laminae less than a centimeter thick. Such delicacy would not survive centuries of sustained earthworm activity. Armour, Chellu, and Andrews, back in 1994, demonstrated experimentally that modern Lumbricus terrestris populations can significantly rearrange stratified deposits within a human lifetime. Balek, in 2002, in reviewing site formation processes across burial contexts, emphasized that bioturbation by worms and other soil fauna is one of the principal forces behind vertical displacement of artifacts in otherwise stable contexts. In North American mounds, however, we find intact burials sealed under multiple undisturbed layers of fill. This is only possible where bioturbation is limited or absent. The case of the Amazon is even more striking. The so-called terra preta soils, anthropogenic dark earths formed through sustained human management, are rich in organic matter and yet retain coherent stratification over thousands of years. If modern invasive worms like Aminthas and Pontoscalex were present from the beginning, this would not be the case. Their current ecological impact is visible in the loss of topsoil structure in degraded areas, yet in archaeological sections, undisturbed horizons remain. Contrast this with the Old World. In Britain, for example, the landscape is replete with Neolithic and Bronze Age megaliths, Avebury, Stonehenge, the Barrows of Wiltshire, but relatively few well-preserved earthworks of the same age. Where earthen mounds do remain, their interiors are often thoroughly mixed. Micromorphological investigations of British burial mounds frequently report homogenized fill, disturbed stratigraphy, and inconsistent artifact depths, all consistent with long-term bioturbation. The soil itself has lost its memory. In Germany, France, and the Balkans, longhouse foundations and palisades can be detected by changes in soil compaction or staining, but any earthen embankments that once accompanied them have largely vanished, reduced to diffuse signatures. In tropical Africa and South Asia, where soil life is even more intense, only the most durable features, charcoal pits, fired walls, dense refuse middens, persist in the record. This discrepancy has often been explained in cultural terms. It is assumed that American cultures preferred earth, while Old World cultures advanced to stone. But this view mistakes effect for cause. In environments where earthen constructions cannot survive, their absence in the record is not evidence of their non-existence. It is evidence of ecological deletion. The stone monuments of the Old World endure not necessarily because their builders were more technologically advanced, but because they had to be. Stone was the only material that could stand against the entropy of life in the ground. This has direct implications for how we periodize human activity. In the Americas, where preservation was more likely, we find rich stratigraphic sequences that allow fine-grained interpretations of ritual, chronology, and construction technique. In Eurasia and Africa, we may be overrepresenting the most durable, that is, the most recent or the most heavily invested activities, while undercounting the more ephemeral practices that once stood beside them. The archaeological visibility of the past is not evenly distributed. It is contingent upon preservation, and preservation is ecological. Therefore, any effort to understand the antiquity of human earth-shaping must first acknowledge that the archaeological record is not an equal witness to all environments. It is profoundly biased in favor of what can endure, not what was most common, most meaningful, or most ancient. This is not a failing of the archaeological method. It is a property of the earth itself. But once we recognize this, we can begin to adjust for it. We can treat the absence of earthworks in some regions not as an indicator of developmental lag, but as the inevitable consequence of a soil system in motion. And we can elevate the surviving earthworks of the Americas not merely as cultural outliers, but as precious, exceptional windows into a world where time, for a while, was allowed to hold its shape. To reconcile this disparity, we need a new framework, one that treats soil biology as a determinant of archaeological possibility. This is not just a call for more careful stratigraphic analysis, nor for a broader sampling of pre-Columbian sites. It is a call to re-evaluate what constitutes a plausible timeline for monumental construction in light of ecological preservation potential. If wormless soils preserve earthworks far beyond the normally assumed lifespan of such constructions, then their apparent absence elsewhere cannot be taken as proof they never existed. Nor can the current age assignments of existing structures be accepted without scrutiny, especially if bioturbation has distorted their original layering. This re-evaluation demands interdisciplinary research, geochemical soil assays, microstratigraphic analyses, void and burrow mapping, ancient DNA sampling, and isotope-based detection of worm activity through time. It requires experimental archaeology to simulate how quickly earthworks degrade under different biotic regimes. And it requires a biogeographical model that integrates worm ecology with glacial history, human migration patterns, and cultural technological strategies. Most of all, it requires us to acknowledge that the material record of the past is not a passive inheritance, but a product of living processes. Processes that are not uniform across space or time. Processes that, like worms, are small but persistent, silent but transformational. By examining where they were and were not, we may begin to see not just how the world was built, but how it has been forgotten. If we accept that ecological constraints shaped early architectural material choices, then we must also account for what happens when those constraints change. The persistence of earthworks in North America, across centuries and climatic regimes, suggests not just an initial opportunity, meaning wormless soil, but also a cultural tradition reinforced by its own success. When a structure lasts, it invites replication. Stability becomes a kind of teacher, a subtle guide shaping the aesthetic and practical vocabulary of a people. In regions where earthen monuments endured, the incentive to shift to more difficult, labor-intensive materials such as stone simply never arose. Earth was sufficient because it remained. This helps explain the relative absence of monumental stone structures in the pre-Columbian North. Aside from a few notable exceptions, dry-laid field walls, petroforms, and select cases of local stone use, the indigenous peoples of temperate North America rarely adopted stone architecture at scale. Their traditions remained overwhelmingly terrestrial, rooted in soil. From the concentric ridges of Poverty Point to the great platform mounds of Cahokia, construction continued in clay, silt, and sand, occasionally capped with gravel, charcoal, or shell, but rarely replaced with quarried rock. The system endured in part because the structures endured. However, the transition to stone is visible where the ecological and cultural conditions change, most strikingly in Mesoamerica. Here, at the juncture of North and Central America, we see the rise of the great cities of the Maya, the Zapotecs, and the Olmec before them, whose builders combined massive earthen platforms with enduring facades and cores of cut stone. The great stepped pyramids of Tikal, Palenque, and Chichen Itza are the architectural culmination of a layered evolution, earthworks as base, stone as expression. In this region, seasonal rains, intense biological activity, and long-term soil instability created an environment where earth alone could no longer serve permanence. The switch to stone was not merely an aesthetic leap, it was a response to changing ecological reality, the same principle that once made Earth viable further north. This mirrors, with geographic inversion, the same progression seen in the Old World. In Neolithic Europe, early ritual landscapes such as those around Avebury and Silbury Hill began in earth, chalk, and timber, materials appropriate to their immediate environments. But over time, these too were succeeded by stone, the sarsen rings, dolmens, and long barrows whose remnants remain today. In both hemispheres, we see a logical sequence. Where preservation fails, architecture hardens, effect becomes cause. The absence of stone in North America is not evidence of technological limitation, but of ecological opportunity. The presence of stone in Mesoamerica and Eurasia is not mere innovation, but adaptation under pressure. Thus, earth and stone are not divergent traditions, but phases within a shared continuum of human environmental design. The transition point, when cultures move from soft to hard material, marks a shift in both need and perception. It suggests a growing awareness that the medium must match the message, that the temporal aspirations of society, be it memory, legacy, ritual, or power, can only be secured when the medium itself resists time. In North America, this moment may have been indefinitely delayed, forestalled by the uncommonly forgiving soils of a postglacial landscape. In Mesoamerica, it arrived more quickly. In Europe and Asia, it was present from the beginning, forced by soil life into architectural permanence. This tri-regional comparison reframes the global story of monumentality. It is not the case that stone is superior or earth inferior, or that cultural progress can be charted by the materials a people use. Rather, we see that the earth itself, alive, dead, or somewhere in between, shapes the human imagination. Where it preserves, it permits continuity. Where it erases, it compels transformation. The divergence of materials is not a divergence of minds, but of environments. And in those environments, a spectrum of equally valid human responses to the problem of time. This inquiry compels a fundamental reconsideration of how we interpret the archaeological record, and by extension, how we understand the trajectory of human and pre-human behavior. What has long appeared to be a sequence of cultural or technological evolution may in fact be the imprint of differential preservation. Material choice, monumentality, and architectural complexity are not merely the products of cognition or cultural ambition. They are filtered, constrained, or permitted by the biological and geological conditions of the ground itself. The presence or absence of earthworms emerges as a surprisingly powerful variable in this equation. It determines not only what lasts, but what becomes visible, and therefore what is studied, periodized, and commemorated. Earthworks that survived in the Americas, preserved by ecological vacancy, provide a counterpoint to the stone-dominated legacies of Eurasia and parts of Africa. When seen in this light, the divergence of materials does not imply divergence of intelligence or capability. It suggests instead a shared behavioral repertoire, parallel traditions of construction and space-making, expressed in different media due to environmental factors. This opens the door to a redefinition of timelines for monumental construction, pushing the potential origins of structured landscapes deeper into the Paleolithic, and perhaps even into pre-sapiens prehistory. It challenges us to reassess what counts as a monument, and to consider how many may have been lost not to time itself, but to the actions of life in the soil. And it forces a shift from a culture-first framework to an ecological archaeological model, in which preservation is understood as a dynamic process, contingent and partial. To grasp the full complexity of human emergence and endurance, we must integrate perspectives from soil science, biogeography, taphonomy, and paleoecology. Only then can we begin to recover a more accurate and comprehensive picture of the deep human past, not as a simple linear ascent, but as a mosaic of adaptive responses to shifting ecological thresholds. We began with a deceptively simple observation. The worms that shape our gardens today were not always here. Their arrival in the post-1600 landscape of North America set in motion an ecological transformation whose archaeological consequences are still unfolding. But seen in reverse, their prior absence created a temporal window, an era in which soil could hold memory and earthworks could endure. That endurance, we now recognize, is not a footnote, it is the key. From this vantage, we affirm the hypothesis that earthworm-induced bioturbation has significantly shaped not only the material selection of ancient builders, but also the archaeological visibility of their works. The choice between earth and stone was not always a measure of cultural difference. It was often a matter of what would last, and where. To move forward, we must read the archaeological record not as a comprehensive account of what was done, but as a partial cross-section of what could survive. We must pair traditional methods with ecological reasoning and resist the temptation to draw civilizational hierarchies from the chance alignments of preservation. and we must remain open to the possibility that many of humanity's earliest and most sophisticated spatial designs have already returned to the soil, lost not through neglect, but through the relentless work of life itself. The future of this inquiry lies not only in the lab or the trench, but in the broader effort to reconceive time, environment, and meaning as interwoven. The deep human past is not gone. Much of it is simply hidden. And if we look again, through the logic of ecology as much as through the tools of archaeology, we may yet recover it.